Okay, now we're going to progress to talking about chemical reactions rather than tables. So if you understood all the table examples, the chemical reactions are no different. It's just like a recipe or a formula to make certain items. So the first question we have here on your worksheet is, what does G mean? Now, this doesn't really have anything to do with stoichiometry. It's just a reminder of chemical reactions and information that's given. So G means gas. So remember, if there's a G, it's a gas. If it's an L, it's a liquid. AQ, aqueous. S is solid. Then it says draw a circle around the coefficients. So remember, we talked about difference between coefficients and subscripts. So there's one coefficient, second coefficient, third coefficient. Coefficients are the big numbers that appear in front of the substance in the chemical reaction. So now that gives us our ratios for one thing to another. So it's 1 mole of nitrogen per 3 moles of hydrogen per 2 moles of ammonia. And now with those ratios, with the ratio of 1 to 3 to 2, I can go anywhere in the reaction when I know one thing. No different than if I know the amount of tables, the amount of tops, or the amount of legs. So we're going to do some practice with the template set up, and then on the next page, you're going to try it on your own. So the first question is how many moles of ammonia can be produced from 2.7 moles of hydrogen gas with excess nitrogen? Now, the first thing is kids get thrown by this term excess. All excess means is that I have plenty of the nitrogen to react with all of the ammonia. For the purposes of stoichiometry, it doesn't matter, but for the purposes of the problem, it's important because you know you have enough of each reactant. Now, remember our steps for train tracks. We start with the number and unit given in the problem. We then put that over 1, and we draw our train track. We take the unit that's here and bring it down. And the unit is moles of hydrogen. And then I want to get to moles of ammonia. So if you don't know what ammonia is, you go up and look at the equation. This is nitrogen, this is hydrogen, this has to be ammonia. So moles of NH3 goes to the top. Now, anytime we are going from moles to moles, we're going to use our coefficients. So you look up in the balanced chemical reaction, and I have a 3 next to hydrogen. Therefore, a 3 goes next to hydrogen down here. I have a 2 next to ammonia, therefore a 2 goes next to the ammonia here. And then all you're left to do is multiply across the top, divide by the bottom, and our answer is 1.8. Okay, second question. How many moles of nitrogen are needed to make exactly 5.25 moles of ammonia? Okay, well, I'm starting with 5.25 moles of ammonia. So that is what I am putting over 1 here. I drew my train track, bring the unit moles of NH3 down. What I want to get to, moles of nitrogen, goes to the top. All I have left to fill in are the numbers. Now, I go up into the balanced equation. There is a 2 next to NH3, so I put a 2 next to NH3. There's a 1 next to N2, so I put a 1 next to N2. Then all I have left to do is I cancel the units, multiply across the top, divide by the bottom, and I'm just going to write it over here so I have a little more space, 2.63 moles of nitrogen. Third example, how many moles of nitrogen are needed to react with 1.4 moles of hydrogen? Take the number and unit, put it here, put it over 1, draw my train track. Moles of hydrogen comes down, moles of nitrogen is where I want to go. Then how I know what numbers to put, I look up in my balanced reaction. So the number next to hydrogen is a 3. The number next to nitrogen is a 1. So now all I have to do is the math, cancel my units, and I am going to get 0.47 moles. Now what I would like you to do is try the problems on the next page.